Consider this. The observable universe stretches roughly 93 billion light-years across and houses at least 2 trillion galaxies, each containing hundreds of billions of stars. NASA's ongoing exoplanet missions have now confirmed more than 6,000 worlds beyond our solar system, with thousands more candidates awaiting verification. Research indicates that at least 1 in 4 Sun-like stars hosts a rocky, Earth-sized planet inside its habitable zone, the orbital band where liquid water can exist on a surface. Scaling that fraction across the Milky Way alone suggests something in the range of 11 billion potentially habitable Earth-sized worlds in our galaxy, rising toward 40 billion when the far more numerous red dwarf stars are included. Given those numbers, the arithmetic of life seems almost generous. If only a tiny fraction of habitable worlds ever produces biology, and only a sliver of those biologies ever reaches civilization, scientists have long argued that the galaxy should be teeming with signals, probes, and perhaps visitors. Yet the sky remains stubbornly silent. No transmissions, no megastructures, no evidence whatsoever of another intelligence anywhere. Physicists call this gut-wrenching mismatch the Fermi Paradox, named for Nobel laureate Enrico Fermi, who crystallized the question over lunch at Los Alamos in 1950 with 4 words that still echo through modern astrophysics: where is everybody? Even restricting attention to our own galaxy strips away most of the daunting complexity. Civilizations in distant galaxies are effectively unreachable. The expansion of the universe means that everything beyond the local group is receding faster than any spacecraft could ever follow. Intergalactic contact is not merely difficult. It is geometrically forbidden on any human-relevant timescale. The Milky Way, at roughly 100,000 light-years across and 13.6 billion years old, has had enormous stretches of time to incubate biology. ESA's Gaia mission revealed that parts of our galaxy's thick disk began forming stars as early as 13 billion years ago, roughly 2 billion years earlier than scientists previously thought. Earth, at 4.5 billion years old, is a relative newcomer. Any civilization that emerged even 1 billion years ahead of us would have had time to colonize the entire galaxy many times over, since computer models show that even modest generation ships could saturate the Milky Way within a few million years. The silence, then, is not just surprising. It is mathematically astonishing. Soviet astronomer Nikolai Kardashev proposed in 1964 that civilizations could be ranked by their energy use. A Type 1 civilization masters all the energy available on its planet. A Type 2 harnesses the full output of its star, a feat that could theoretically involve wrapping that star in an energy-collecting shell known as a Dyson sphere. A Type 3 civilization controls the entire energy budget of its galaxy, wielding power so far beyond our comprehension that such a species would be functionally indistinguishable from a god. Carl Sagan later refined the scale to allow decimal values, placing Earth in 1973 at roughly 0.7 on this spectrum. Remarkably, that number has barely moved. A 2023 machine learning study published in Scientific Reports calculated humanity's current Kardashev rating at precisely 0.7276 and projected that at the current pace of energy development, we will reach only 0.7449 by 2060. That same study concluded that if present energy strategies remain unchanged, it may take millennia for civilization to reach the Type 1 threshold. That counterintuitive result challenges the popular assumption that technological progress is fast and inevitable. We are not, by any measure, close to becoming a planetary civilization, let alone a stellar or galactic one. The gap between where we stand and what a Type 3 civilization would look like is not large. It is almost incomprehensibly vast. One of the most intellectually vertiginous ideas in modern science is the Great Filter, a concept introduced by economist Robin Hanson in 1996. The core argument is elegant and terrifying. Given the enormous number of potentially habitable planets and the age of the galaxy, at least one step on the path from chemistry to spacefaring civilization must be extraordinarily improbable. Something is filtering life out before it becomes visible. If the filter is behind us, perhaps the jump from simple chemistry to self-replicating molecules is cosmically rare, or the emergence of complex cells required a nearly impossible sequence of accidents. Then, humanity is likely a genuine cosmic rarity, possibly the first advanced civilization in the Milky Way. That conclusion, while strange, is actually the hopeful scenario. A 2026 analysis argues that several sequential improbable events, including the Theia impact that may have triggered plate tectonics, the rise of the complex cell, and the dominance of parenting mammals after the dinosaur extinction, together constitute a plausible past filter that may have left us nearly alone. If the filter lies ahead, it means civilizations routinely reach something close to our current level before being extinguished by their own inventions. Nuclear weapons, engineered pathogens, climate destabilization, and artificial intelligence have all been proposed as filter candidates. A 2024 paper by astrophysicist Michael Garrett at the University of Manchester argues specifically that AI weaponization by competing factions within a civilization could destroy it before it ever spreads to other planets, offering a chilling explanation for why the galaxy remains quiet. Science currently offers no confirmed evidence of life beyond Earth. 75 years of SETI searches, scanning radio frequencies, laser channels, and now the possibility of quantum communications have returned nothing definitive. A June 2025 analysis noted that while we now know at least 25% of stars host rocky habitable zone planets, detecting biosignatures remains far beyond current technology. The Habitable Worlds Observatory, a proposed NASA flagship telescope, represents humanity's next serious attempt to directly image nearby Earth-like worlds for atmospheric signs of life. There is a final possibility that science cannot dismiss. We are alone. Not alone in the sense that life never arose elsewhere, but alone in the sense that no other civilization has survived long enough or advanced far enough to leave a detectable mark. Each intelligent species, the hypothesis suggests, burns brightly and briefly before being extinguished by some internal catastrophe that every sufficiently complex society eventually faces. The universe, in this reading, is littered with the silent ruins of civilizations that almost made it. If it is true that we are alone, then the fragile thread of awareness that currently runs through one pale blue dot in a quiet corner of the Milky Way may represent something extraordinary and vanishingly rare. Consciousness itself examining the cosmos. The Fermi Paradox is not just a puzzle for astronomers. It is a mirror. How civilizations answer the question of their own cosmic loneliness may determine whether they survive long enough to stop being lonely. Thanks for watching Fermi's Paradox. If you have anything to add, drop a comment below. Don't forget to like and subscribe for more videos exploring the world around us.